I remember going on a great hot air balloon ride one time, and it was amazing. But I was relying on my captain to really understand the principles of both hot air and ballast to get us from where we started to where we ended up. And if we want to fly our NSX topologies, we're going to need to understand the principles of VXLAN technology. So, what does VXLAN bring to the table? VXLAN functions because it's able to differentiate between the virtual machine and the host that provides access to that virtual machine. Those hosts are going to exist on traditional VLANs. And therefore, our network is there to function as a transport network. It is a delivery system. A delivery system for what? For ESXi functions. But our physical network is not there to support the intercommunication between the virtual machines. That's what the VXLAN is for. Let me pull over and park here for just a second. Over on the right-hand side, we're looking at an example of how we create a VPN tunnel. There's an endpoint communication protocol that's going to occur over the internet, which is really just a transport network. I'm going to have my public IP address that I use to connect to the public IP address of the VPN server, but then once I've connected, the client's given a private IP address that can function through the tunnel that is created, unseen by the transport network. So I could have an IP packet with an HTTP header, which is then encapsulated in an IP packet with an L2TP IPsec VPN header. Over the transport network, only the outside portion is seen. Once we cross into the VPN connection, the inner portion is seen. This is IP over IP, or layer 3 over layer 3 encapsulation. I told you that to tell you this. VXLAN technology is also going to be about encapsulation. It's also going to have endpoints. But the key difference is that VXLAN is going to be layer 2 packets over layer 3. All of this is going to be transparent to the virtual machine. The work is being done by the ESXi host to provide access to the virtual machines. So if we have a web front-end virtual machine that is actually pulling content from a database back-end, we're going to have VM-to-VM communication. And at this point, our network is just set up to support transport of ESXi itself. We don't have VLANs for these virtual machines to rest in that are recognized on that transport network. So if we envision an Ethernet frame coming from that web front end, and that frame's going to leave the virtual network card and hit ESXi, and then the VXLAN magic starts to happen. We're going to drop the original frame check sequence. Then ESXi is going to add a VXLAN header. And the most important thing to know is in there is the VXLAN network identifier, or the VNI. That is a 24-bit identifier that's like a VLAN, only it's 24 bits. By the way, if you want to do the math, 2 to the 24th power gives you about 16 million different possible networks. And this allows us the freedom that we need. In NSX, by the way, these VXLAN numbers begin at 5,000 to avoid any confusion with the VLAN numbers that go up to 4,094. Now, outside that VXLAN header, we're going to have an outer UDP header. And we need to start thinking about where we're coming from and where we're going. Each ESXi host is going to have a way to reference it in the context of VXLAN, and that's by referring to each ESXi host as a VTEP, a VXLAN tunnel endpoint. So when we go back to that transport network, it needs to support interconnecting our VTEPs. The VXLAN protocol referencing a VTEP is going to reference port 8472. And in fact, the source port of the UDP packet is uniquely identified by creating a hash of the layer 2, 3, and 4 headers. Outside of the UDP header, we're going to have our outer IP header with its source and destination IP addresses. What are those IP addresses? Those are going to be the IP addresses of the VTEPs themselves. And now ESXi itself is going to be represented with its own virtual network interface, getting on the network and interacting with our switch. And so that's where the outer Ethernet header comes in. So once again, the source and destination MAC addresses are going to be those of the VTEP interfaces of ESXi. Now, the addition of all this new header information is an extra 50 bytes worth of traffic. And that is why, in order to support interconnection between our VTEPs, we must support jumbo frames everywhere a VXLAN packet is going to traverse. Now, if we do the math and add 50 to 1500, we get 1550, but VMware specifically has as their minimum 1600 byte frames supported in the transit network in order to use VXLAN. So now the frame can easily traverse the switch network. If those ESXi hosts were in different VLANs, if necessary, we could even go through the routed network. If they were even in different data centers, we could traverse that as well, because it's just an IP packet with all of this embedded content within it. Again, as long as we have jumbo frame support end-to-end, we can utilize the VXLAN technology. When it gets to that endpoint ESXi VTEP, think like a VPN. What's going to end up happening? We're going to validate what we see here, make sure, is it for me? Yes, it is, process it, and then we're going to de-encapsulate it. We'll know which VNI to forward that to because it'll be right there in the frame. Once that's been validated, then we can forward it to the specific network interface that needs to receive it. We will have to strip off the frame check sequence and add one new frame check sequence just for this last leg of the journey, but then the destination frame is received as it was originally intended. Where a VLAN is just tagging, a VXLAN is encapsulation, and so it requires endpoints. But that layer 2 source MAC address and destination MAC address are able to traverse even through routed networks and end up at the endpoint untouched. To the virtual machines themselves, they feel like they're connected to the same logical switch, which is actually the term that the NSX uses to reference a VNI. Because a VNI is a shared network, a logical switch that these VMs are going to be plugged into. I had a lot of fun breaking this down with you. I hope this has been informative, and I'd like to thank you for viewing.